Hi, today we're going to learn how to solve equations and inequalities with logarithms. So here we have log base 3 of x squared minus 15 is equal to log base 3 of 2x. So how do we solve this? First, we need to get rid of the logarithms. So how would we do this? First, we need to realize that this logarithm equals this logarithm, just like 4 equals 4. Kind of random example, but it will show us what we're doing. So if you take 3 to the 4th power and 3 to the 4th power over here, we know that these two are equal because we have the same base and 4 equals 4. Our exponents are the same. So likewise, if we take 3 to the power of this log, we know that we can have an equality here if we take 3 to the power of this log. So this is also an equal statement. So how do we solve this? Because it looks even more complex now. Well, if we just look at this half here, we are taking 3 to the log base 3 of x squared minus 15, which means right here, this log means whatever power will take 3 up to x squared minus 15. So we know that if we're taking 3 to the power, which will make 3 turn into x squared minus 15, then we're just going to get x squared minus 15. Very simple. Over here, we are taking 3 to the power, which will take 3 up to 2x. So we're going to get 2x here. And we don't know what the power is, but we know that it will make 3 turn into 2x. So this is our simplified equation here. And so now we just solve it simply as a quadratic. X squared minus 2x minus 15 equals 0. So we have x minus 5 times x plus 3 equals 0. So our solutions will be x equals 5 and x equals negative 3. But we have to check this. So let's plug in 5. Let's plug in 5 to our original equation. If we do that, we get, make some room for ourselves, log base 3. If we put a 5 in here, we're going to get 25 minus 15, which is 10, equals log base 3 of 10, which is true. So this is a good answer. Let's try negative 3. Log base 3 of, let's see, if we plug in negative 3 here, we're going to get 9 minus 15, so negative 6, equals log base 3 of negative 6. But there's a problem here, because log base 3 of negative 6 doesn't make any sense, because 3 to whatever power cannot equal negative 6, so this doesn't exist. Especially since in our logarithmic equation, the log graph generally has a shape that looks like this. So if we have an x being what's in this parentheses here, being a negative number, that's undefined. So negative 3 is not an answer, so our answer here is 5. Let's try an inequality now. So here we have log base 4 of x plus 3 is greater than log base 4 of 2x plus 1. So let's use the same technique as we did before and take this side and do 4 to the power of this log, and then do 4 to the power of this log. And this works because the base here is 4, and the base that we're applying is also 4. And the base of each log is the same. So now we know from our properties of logarithms that this statement over here simplifies to x plus 3, because you're taking 4 to the power that will make 4 turn into x plus 3. And then over here we still have our greater than sign there. And over here we have 2x plus 1. And so now we can simplify this just like any other inequality, and we get 2 is greater than x, or x is less than 2 would be an easier way to write it. So this is our constraint from this. But we also have 2 more constraints to consider. And these constraints are very clear if we look at what we have in these parentheses here, both of these logs. So we know that x plus 3 must be greater than 0, because if it's less than or equal to 0, then this logarithm here is undefined. So x is greater than negative 3. Also, we know that 2x plus 1 is greater than 0 as well. So we know that x is greater than negative 1/2. And so we know that this constraint is a little bit redundant, so we can write this relation simply as negative 1/2 is less than x is less than 2. And so this would be our answer to this inequality here.